Hello everyone, and week 2, regression. How's everyone doing today? Okay, so last week we talked about correlation. We talked about how to use Vassar stats to compute the R, the correlation coefficient, with a R of 1 and an R of -1 being perfect linear correlations. Anything between those two values being less than a perfect correlation. We talked about how to determine whether the correlation was significant or not, meaning if the p was less than the alpha, then we could reject the null hypothesis that there is a zero correlation in the population in favor of the alternative, which is that there is a non-zero or some correlation in the population. So this week we move on to regression. The two have different purposes. Correlation will not allow you to predict any criterion variables based on predictor variables. As you'll look in your text, the y is usually called the criteria variable. The x is usually called the predictor variable. Now, once again, because the x is called the predictor variable, doesn't mean that x has caused y. Now, you may think in this situation that hours of study are the direct cause of a score on a calculus test, but in the vast majority of situations, this may not be the cause of that, but they are associated, or this may not be the cause of that. Okay, we leave that for experimental research. All right, let's figure out what our regression line is. Now, when we go to Vassar stats, if you look at the screenshots that are provided in the content, you will also see that there is a slope provided for these sets of data, and that slope is 13. And there is also a y-intercept, and that y-intercept is -9. Okay? Now, what does the slope and the y-intercept allow us to do? Well, the slope and the y-intercept allows us to create what's called a regression equation. And a regression equation is simply an equation that relates the x and the y, or the predictor and the criterion variable, in a way such that we can choose predictor variables and get criterion variables based on an equation, based on a prediction. Now, the regression line is also called the line of best fit. And we don't go into why the regression line is what it is. That's another topic. But the regression line allows us to predict values. So this is also something that you could consider putting in your dissertation or a research paper. So let's just take an example. Let's say we wanted to know what 10 hours of studying might bring in terms of a test score. So I'm going to substitute 10 in for x. And I'm going to get 130 minus 9, which is equal to 121. So that would be a score of 121 on the calculus test. So I can put any x value in I want and make a reasonable prediction of what the criterion variable will be. Now, regression is often put in dissertations and research papers to allow those that read the papers to make predictions. That is one of the benefits of it. You would like the information that you were reported on to be useful. One thing to keep in mind, most research papers deal with what is called multiple regression. We don't deal with multiple regression in this course. We deal with simple regression. Simple regression. And multiple regression is quite different. Multiple regression uses multiple x values as coefficients to determine a y value. And how those models are developed is extremely complicated. We won't be doing them now, but simple regression is another tool you can use along with correlation to create a good methodology for showing association. Well, thank you and have a good day.